Hi guys, this is Prabhat. Today I'm going to explain you about my project on bike sharing count prediction using machine learning. The traffic is the biggest problem we are facing nowadays, and to rectify this problem, government has introduced various modes of public transport. We can see the most recently they have introduced the metro. These things need more and more investment and also takes time for establishment. Even though these government solution does not rectify the problem entirely. If you see, only the people who travel for long distances, not long, a little bit longer distances, only use these public transport. If their destination is around 5 kilometers, something around like that radius, they only use their vehicle itself then. So even though if as we see, vehicles, they don't even have vehicles because most of them people are from middle class and lower middle class families, which they totally rely on these public transports. So even though if they have the vehicle, they need we they can't maintain it. I mean, they can't maintain the bike. As we see, the petrol rates are also increasing day by day, which further creates problems for them. So to rectify all these problems, in this project I have introduced bike sharing as a solution. This bike sharing is not like olden days bike sharing where there is an involvement of a third party vendor, where we go there and go somewhere else and we have to take like that. It's not like that. As we are living in a automated world, this bike sharing is also new generation bike sharing is also made an automated one. Starting from the membership, taking the bike for rent and returning it back, all are made automatic. Which by which we can save the time. We can also know the availability of the vehicle. By all these, the services also got better. As we see, the payment is also made online, by which we can conclude this bike renting system is became more new generation bike renting system became more trustable and more efficient one. Okay, the objective, coming to the objective of this project, we is to select the suitable regression algorithm for our bike sharing count prediction and predict it by using it. Okay, later on, we will decide which attributes are more affecting these bike sharing count using future importance and regression and future importance. Okay, coming to the data set, this is the data set. We can see the instant, day, season, year. This is count. I will explain these in the here. Okay, see now, these are the attributes information. Instant means nothing but record index. DTDV means date. Seasons, we have 4 seasons which represent 4 numbers here. And year, I have taken 2 years within the 2011 and 2012. We all know the month, we have 12 months in an year, and 24 hours for a day. And holiday means whether it is a holiday or not. Weekdays means days of the week. Working day, if there is neither working nor holiday, then it's one, otherwise it will take as it zero. Okay, now coming to the weather sheet, we have four, again we have 4 numbers here which represents these things. If one means it is either clear or few clouds are there, partly cloudy, and etc. If we see the second one, it with cloudy and mist, or with the broken clouds or and mist and etc. Like this, it's for all the four. It's we have introduced here, I mean we have explained here. Later on, if you see the temp is nothing but normalized temperature in Celsius, where the formula goes like this: minimum temperature, maximum temperature using. Okay, next the a temp is feeling temperature. The formula goes like this for that. Coming to the humidity, we know the humidity, and here we have taken the humidity value maximum as 100, and wind speed is also we have taken maximum as 67. We have casual means count of casual users, registered means count of registered users, Count means count of total rental bikes, include means the inclusion of casual and registered total. Okay. Now the methodology. Initially I have done the descriptive analysis where I have splitted the data sets for training, validation and testing. Later I have removed the null values, means I have done the missing value analysis where it will check whether there are any null values or not. I will explain it briefly later part. Next, the outlier analysis I have done where I have created a box plots and removed the outliers for the data set using IQR and etc. I will explain it later. After this, I have done the correlation analysis. Based on the correlation analysis, some of the attributes I have dismissed them. Then we do this model selection. Later, the most important step is I have after this result. I got result as random forest is the best one. So for for this we perform model random forest for the count, uh, bike sharing count. Okay. Now the random forest regression can be doing in we can do this random forest in two methods. One, I have taken the data sets of training, validation and testing, and the other I have used this k fold where I have taken value k as 3, and so it is threefold cross validation. I will brief it later. And coming to this uh, implementation for these k fold and everything for each split. Finally we can check the future importance and attributes. Okay. Which are the prominent attributes, so we will find it by using future importance of each and every future ranking and plotting a future importance graph. Okay. I will explain each and every step by step. Okay. Now coming to the descriptive analysis. Here initially we load the CSV file and divide the attributes based on their future important categories. This split will be further be helpful for validation, testing and training. Okay. Later we find all the statistical information for each integer column. Later we also find these categorical attributes. Everything I will explain brief. First I will show you how to open the code. For initially I have opened an Anaconda prompt. First we have to create a environment. The code for it will be conda env hyphen hyphen, and here I will give the file name, but I have already created it, so I will just activate it. Activate activate data analysis. Okay, I have activated it. Now I will open. I have done my project using Jupyter Notebook, so I will just open it. Okay, Jupyter Notebook. Yeah, if you see here, Jupyter Notebook, this is the bike sharing count prediction. Okay, as I said before, these are all the data. I have loaded the data from the data loader, and these are all the imported things which from the environment and etc. Yeah, I have used this kernel as my model prediction and matrices. I have used this kernel as function. Okay, I have imported all these whatever I want to do. These regression models, all the regression models. I even this random forest also I have taken from this kernel function. Okay. Now I have taken this seed value as 100 to make results reproductive. Okay. Sorry, reproducible. Initially I have loaded the data. This is my path for the data, and I have divided the train and val and test for this data set, and the full data will be this thing. Full data means whole data here will be there. I have divided my data into two, which I have said categorical and numerical. Okay. Based on this, categorical means only 1 2 3 or true or false, like this will be there. Numerical means integers. As we know, temperature is calculated its total like that. Okay, in integral values. Okay, these features involves both categorical and numeric, but we have taken this target as count. That is what our target is. This is the response variable, and these are all predictor variables. Okay, this is our response. Only we will have always one response variable, and some all others, many number, we can have many number of predictor variables. I'll just run this. See, first I will run this. It will run. Next I just plotted what are the data, in dataset, what are my columns. Just I have plotted it. I will just run it. I will show you what are the columns, and this will print. I have taken 3. Whatever we want, we can take it. How many numbers randomly it will print the data. Okay, now I have considered, as we mentioned here, statistical information for each integral column. See, if you see, I have taken the number future, and I have printed the count value, mean of it, standard deviation of each and every future value. Okay, number future, integral future. Later, what as I said before, using categorical attributes. For categorical attributes, I have found discount, unique value, top value, and everything. See, if you see, I will run this thing also once. Okay, see, this is the same, and this will be the same again. I will just not run it because already I have run. Okay, now later what will we do is see the count here. There are total of 17379 rows. Okay, the rows in this Excel file. The rows in this, what's happening? Okay, the rows in this Excel file. Now these are now later. What's the next one? This is next one is missing value analysis, where what is missing value? The missing value analysis will check whether the data set is having null values or not. Null values means nothing but not a number kind of things, like some character functions, like. Okay, now what happened? If we have any null values, it will replace them with preceding or succeeding values. Okay, in I mean the top one, I mean above value or below value of it. Okay, where in our case we don't have any. That's what I have run here. I will run it again, no problem. Okay, later what I have done, see, there are all are false. Okay, for instant and everything it is false, means it's nothing but there are no null values. Later, these are all outlier analysis. Here I have plotted the box plot, where I have taken y axis as count and the x axis depending on it for each and everything. If you see, oh yeah, sorry, if you see here, I have taken this scale as this thing, and figure and axis I have to plot this. I have used this SNS function, where y axis as count. For only count I have taken x and y, both will be the count for this, means I have taken this orientation, right? Okay, and here 0 0 means this place it will print like that. Now if you see count and month, count and weather, count and work days, count and hour, count and temperature. You see, I have given the names for each and everything. Box plot of the count for count on itself, box plot of the count for months, where count and months are I have plotted for the count and months. Similarly for all, box plot on count across weather situations, box plot count. I will run this thing also. See, it will take some time. By then, see, this is the last one, right? That is what it is showing. This is the last one, and if you see count and it's for count, this box plot is for count, this is for count and month, and this is for count and weather situation, this is count for and working day, and etc. If you see all these, you can check which is the good one, which is good situation. I will explain you here. See, for consider this thing, hour of the day. No, consider this working day thing. I have mentioned it here. Working day box plot. We see the use of bikes during work days is more. That's what, when compared to the weekends. See, this is for work day. It is more. and this is the weekend. I mean, this is the workday and this is the weekend. I think 0 and 1 accordingly. Okay. Later, if you see this hourly analysis with respect to count, you can see 8 a.m. 8 a.m. In one 8 a.m. and 5 p.m. Are certain time intervals where the use of these vehicles are more. I mean, this bike count is increasing. Means we are using more bikes then. Okay. Now removal of outlier analysis here. Simply wait. Okay. Removal of outlier analysis. I will just remove the outliers. What is outliers and etc. I will explain you. uh, I have you. Okay, let me go there only. Okay. Array. Okay, outlier analysis. If you see, I have removed the data outliers. What is the removal? I am explained here. I have explained here. Here initially we consider the distribution plot of all count values and these compared to the corresponding normal distribution. See, if you see here, they are compared. These values count values are compared with its normal distribution. Then what happened here? You can see they do not match entirely. That's what it is, not a perfect normal distribution. So what we do is using interquartile range and median. This is the formula for interquartile range, what I have shown in this code. Q1 Q3 IQR means interquartile range, lower bound and upper bound. For this, by using which we use the, I mean, we'll get the samples, what how many samples are there initially. Later, using this quartile information, we will get we will remove the outliers. What are outliers? Simply, if you see in this, if you see here, uh, only 600 to 800 here. If you see here, they are only it has reduced to 500. Why? Because these are all values do not change. So these are all outliers. That's what I am trying to explain. Okay. Next, what is next? The correlation analysis. I simply use this correlation analysis here. I will run this thing also once for you guys. Okay, and it will be running. This I have created a matrix. I have used the heat map for correlation analysis and etc. See, I can give you here color and what scale. This is the scale and what how many inches and etc. size. And if you see here, one for temp and day temp, both are having high correlation. See, I have explained here. See, for a correlation matrix for the numeric features I have created using for the bike sharing one, and the most promising variables are here, both temp and hour. I will explain you why later. We can also see the values of correlation is very strong for both. Yeah, the correlation is very strong for both temp and day temp. So we will dismiss one here. Anyone we can dismiss. I have dismissed a temp here. For dismissing it, I have run the code here. See this code run and the output these many number of outliers before, and these without outliers. This is the data, this is with outliers. And now I will run this code also. See, later I have removed the a temp value. Now coming to our model selection. Okay, model selection, I have taken the x value from the train data set. What is this train preprocessed is nothing but from the train preprocessed is nothing from this here, from this outlier without outliers. Okay, after removing the outliers, I have taken x train, y train, and I have sorted this thing. Just simply I have sorted using the values where the I have described the what is xval. Xval is from futures, and yval is the target. Here also future and target. Val means nothing but validation. Test means nothing but test. Testing, training, and validation data sets. I have taken the x value, y value from there. Okay. X is nothing comes from the future attributes, and the y is coming from the target attribute of the same row. Okay. Now, I have created a table for model mean square error R square. I have defined the model as see this, where I have described all the functions including random forest, SDRG. If you see, SVM will have two according to its kernel value. Okay, see the kernel is linear. If it is RBF, it is like that, and K neighbor classification. Everything I have done. Okay, later we will get an output like this. I will run it, and it will be running, and I will show you in this. See, that is what I have explained here. Yeah, what on which basis we will do this? We will use these four formulas, where y and x values means x of the particular are taken like this, and n is the number of like that. I will not explain all these things. These are the formulas which we will use in general. Absolute means the modulus of this thing, and etc. I cannot explain you all this now. See, this is the mean square error, mean absolute error, root mean square log error, and r square score. These are all the overview metrics which we will use in all in the entire project. Okay, okay. See, it got. I have run it. Okay, no, it's running again. It will take some time. I'll show you what is the output here. See, this is the output. If you see the output, the mean square error, as we know, mean square error should be the least, then it is the best. Whereas the R square score should be the highest, which will be the best. Where we can see for the random forest, this is the least and this is the highest. So we choose random forest regression for our model. The best one is, best model for our bike sharing is random forest regression. Okay, so that's what I have done here. I think it's got run now, but yeah, it's got run. See, this is the same, these are the same values. Later what we will do, on basis of data sets, I have chosen to take evaluate random forest regression for training, testing and validation, where I have the same, I have created the table according to the data set, and these are the all the values, these metrics values, and I have defined the model as like this. I have taken the random forest regression, and see here I have taken 200, means it will create 200 in 200 of these what we say 200 of trees, decision trees. I will explain you later. Okay, this is the code word. See, for the predict x and y values, we will take the same here. I have forgot to predict. I have forgot to say. I have created a model fit according to x train, y train, and I have introduced this virus as prediction of x val, and I have defined the MSC accordingly, and I have created the table. Same here. I have predicted this predict from this x attribute of each and every data set, and I will predict all these things. Okay, I mean, I will conclude all these things. I will get the output like this. I will run this cell also. It will be running. By then I can explain you what is this random forest. See, random forest is an advanced type of algorithm using which we generate many number of individual decision trees. In our case, I have taken 200, and for each and every addition tree we feed the observations. That's what we do, the feeding of observations, and after which we will get an output. Here in our case it is 200, and different subsamples we will take from the data set. It will take from the data set. If this is the function, that is what I said, random forest regression is the function for random forest, and using which we find all these values. That's what I have said. Now for training, validation and testing, I am using these for these data sets. I am finding these matrices. Okay, I think it will get run by now. Yeah, if you see here also you can say training is the best one, and coming training is best as MSC is low for this, MA is low for this, as we all know, and RMSLE is low for this, and R score is high for this testing. As so we can say that testing is the best data set we can see select for this model. Whereas we can also say that validation and testing are little bit same, nearer. Validation and testing datasets, we will see the nearer. They both are closest to each other for these matrices. Okay, that's what. I mean the error percentage will be the same, near, I mean close for these two. Next, that's what I will say. I'm saying, if you see, that is what I have said here. Now coming to, I mean, I will do this. I will come to K-fold later. I will show you the future importance. The future importance will get the future ranking of each and every attribute. This is the output, where we can see the hover and temperature are the best. We can conclude by this. This itself, hover and temperature is best for, if you take this testing training data sets and okay, this is for validation, data set. I will show you the code. See, importances, this is the code for the future importances. I have taken this model, tree model estimators. I have used some functions for this. Later on, if you see, I have taken future and see xval. I have taken the xval is from validation data set, so this belongs to the validation thing. I will run each and everything. Run. Yeah, if you see, this is the output. And coming to this, you can see, I can change the color. The initially I have taken in the PPT I have taken red. Here dark red I have taken in PPT. Here I have taken cauliflower color. I have set the figure size, and I have given the title and etc. I have given accordingly the value validation. I have taken from that, and I have concluded the random forest in a sorted way. Okay, that's what here I have done. And we can see the hover and temperature remaining all are negligible. These are the important attributes that will we use. I mean, that has more influence in predicting the count value. Okay, now this is for normal, for the tree data sets. If you want to see for the random forest using k-fold algorithm, see here, the data for loader file which I have mentioned before, we have used there. That is nothing but we have taken the we have chosen the path of it. Here, what is it? We have defined the function get header. What is get header? The columns will get and we will get the data sets from the pandas frame using this get data, where the splitting of training, validation and testing is done here. That's what we use it, test, train, val, right? That's what I have done. That's what I am showing you. 60%, 80% of this train and validation and the test will be the normal. The get full data means the complete data. These are all the functions which we use in this data loader. Okay, I'm just running it. It will not show anything else. I'm not printing anything. Okay, now if you see, yeah, the same, I have changed this random forest. I have classified this class, this function. What is this function? I have defined here. I have chosen the path of this, and I have taken the seed as 100, and I have loaded the data, and full data I have loaded as this. I have just changed the these variables. Yeah, these variables I have just changed these variables. Okay, the remaining are all same. See, the futures are these and the target is this, and using which we converted this panda frame. Okay, and we defined the model. That's what random forest regression. We using 100 here and 200 as the number of decision trees. Okay, I have to, for the saving means the storing the random forest in the disk. This function is useful, and the load model and the random size parameter sets, which means nothing but number of trees in random forest, how many number of trees are there, and everything I have given. These are all given values in the random grid, using which I have defined the random forest regression function. Okay, now what happened later? I am using this model, and I'm just using this model. Okay, and if you see, train and test and train and evaluating the test, I have defined these functions. Later, using that model, this model, I am printing the value. Okay, I'm creating a table where we will have this MSE, MAE and a score RMSLE. where how will be the splitting this kf using kf function, I mean the k-fold cross validation. I have defined this function here. It's nothing but it will have these all things. I mean splitting, the splitting is done here. If you see, the k-fold means I have taken the number of splits as 3, kf means, and I have used this kf here to for the splitting, using which we can the normal this mean median mode, as we all know, predictor variable and everything already we predefined, and we will find the mean of each all and each set. I will explain you the output here. Okay, this is for the selecting data, and these are the future importance that which is normal. Okay, the output will be like this. I will run it. It will take some time as it is a big code. By then we will go what is k-fold and everything. Okay, k-fold means I have, as I said, k as 3, where it will split into 3 parts and perform all this training and testing and validation to it, and uh, later we will find the values of MSCMA and R square score for all each split. To improve the accuracy of prediction, we will find the mean of this. Like if you see here, the mean of all the 3 splits will be this, the mean of all these 3 errors will be this, and the mean of all these errors will be this, and the mean of all the score is this. Okay, that's what the mean. I have found the mean. If you see, the first split is the best here, as it has lowest lowest mean square and mean absolute value. Coming to the this mean error, we will take the mean absolute as for consideration for the random forest. Okay, that's what I have explained here. Somebody, yeah, see, if you see the final model, the by absolute mean absolute error of 44.3, the mean of mean absolute errors is 44.30, which is an average and of the 3 splits that we derived from the threefold validation. And if you want to find the best split, that is the split one, which I have mentioned here. And the future importance of these, here we will take the future importance. If you go for the future importance, we have taken for the split one here, where we can see the output here like this. And as split one is the best split, we have taken split rankings here. The best rank, highest rank will be this. I have sorted it, I mean in the code it will be sorted, and these hour and temperature are defined same. See this, if you see the future importance of both, that hour and temperature are the for both of these, hour and temperature is the best. So whatever the model we use, whatever the data sets we take, the conclusion will be the same. Conclusion will be the same, but there will be different methods. That's what I am trying to explain. Okay, the conclusion is here nothing but what as I said, hour and temperature are having high correlation count, bike sharing for the bike sharing count. That's what the conclusion is. And for the future work, yeah, the conclusion, that is what the conclusion. By using all these things, are these matrices, we and the random forest which we define the which model is the best for our data set, and we have used this the best data set for predicting the values. Okay, where we have taken two, I mean as I said, I have used the training validation testing data set, and also the threefold split. Okay, if you this is the small data, I mean this if you compare, this will be the smallest small data. As if you take the large data sets for random forest, this sklearn function will not work good. It will stop, and it may also crash. Okay, sometimes. So I have introduced various functions like Spark ML, where it will take the from Apache datasets, it will take the Apache Cassandra, which will be the fastest one, 100 times faster than normal any classification algorithm. That's what I have said here. That is the conclusion. Okay, I will just show you the code. I got the output by now, I think. Sorry, not this. Yeah, see here we got the output, the same, the highest will be this. I have sorted it. That's what I will say you here. See, if you see here, there will be a sorting one. See, this function is used for sorting. See, got get sorted feature importance for model. That's what initially it will sort the future rankings for this. That's what using which here I have given didn't give any scale, so it is showing like this. Normally if you give any scale, it will show the output clearly. That's it. Thank you for hearing.